All right, here we are back at math. Today is our third lesson of this unit, and it's actually the last lesson before your first quiz. So let's make sure we finish strong and have good notes that we can use on the quiz. Today you're going to learn to write expressions between tables and sequences. Make sure you're putting down today's date and page number on your page before moving on. All right, now that you got today's date, page number, and the big idea down, let's get started. Your warm-up today, I need you to find the next three terms in each sequence. So number one goes 7, 10, 13, 16. What's the next number? The next number after that, next number after that. Fill in the blanks. Come back once you figured them out. Good luck. So here is the answers. For number one, it was 19, 22, and 25. You're adding by 3 in the next sequence. For number two, it went 108, 105, 88, 71, 54, and then 37, 20, and 3. You were subtracting by 3 every single, I'm sorry, subtracting by 17 every single round. And then finally, you had to multiply by 2 every single one up. So if we considered these variables, okay, variables, that would mean that it could change every single time. If those are variables, this is a constant. Okay? And constants tell us what we do every single time. So really, whatever it was, this could be that the number would be n plus 3, n minus 17, and n or 2n, or n times 2, all those would tell us what to do. So if we put in any of the numbers before it, and then added or subtracted as it said, you could get it. And that's what we're going to work on today. So we're going to be working on trying to translate between tables and between expressions, trying to solve different things that we see. Let's get started. All right, let's look at the scenario, depending on how you pronounce it. In 2004, international chess master Andrew Martin, and that's not really Andrew, that's a cartoon, but I just want to make sure you're aware of that. Andrew Martin broke a world record by playing 321 games of chess at the same time. I wonder if he was playing 321 other people or it was a computer. I don't know for sure. It'd be interesting to look that up. Each game required 32 chess pieces, and that's 16 pieces per player. And the table shows the number of pieces needed for different numbers of games. So if he was playing, just one person, that would be 32 pieces. Okay, 8 pawns, 2 rooks, 2 knights, 2 bishops, your king and your queen. So there's double sets of that. So it's 32 pieces. When he played 2 games, look at how many pieces are needed, 64. 3 games, 96 pieces. And n games would be any number you want to put in there. It's a variable. But what we notice here is that every single game is going to count for 32 pieces. You're going to have to multiply it. So really, we could figure out any amount of the games he played to figure out how many pieces he had. And that would be able to, then we'd be able to figure out how many pieces. So if we wanted to know, if we wanted to change n and put 321 in there, we could easily figure out how many pieces that is, because then you just have to replace n with 321 there, and we would replace n times 321 here. And 32 times 321, we can work through over here. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Put a 0 here to represent we're done with the ones. 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. So how many pieces did he play with? It would be 10,272 pieces. That's not counting the boards themselves. That's a lot of pieces that Andrew had to be aware of at one time. Not only did he have to be aware of the other person's pieces, he had to be aware of his own. So let's talk about how we can use this information to solve some other scenarios. All right, so now you're going to put down practice as your subheading. And we're going to look at this scenario here. So we're looking at 2 different things, two different bits of information that are put into a table for us to try to decipher. So what we're looking at is Spike and Rusty. So Spike's age and Rusty's age. So whenever Spike is one age, Rusty's another. Okay? So looking at how two people get older and what their ages are. So for here, we can see Spike is 2 years old, Rusty's 6. When Spike is 3 years old, Rusty's 7. When Spike is 4 years old, Rusty's 8. So we're trying to figure out how much older is Rusty than Spike every year. And then we could put in any year for infinity, or until Spike's dead, and we call that variable A for age. We could put a little expression together to be able to solve that. Okay? Well, the one thing we notice is that between 2 and 6, it's a difference of 4. Between 3 and 7, it's a difference of 4. Between 4 and 8, it's a difference of 4. So really, all we need to do is to solve for Rusty's age, we just need to take A and add 4. And that will include any age of Spike's. We'll know what Rusty's is. Okay? So that's the expression that we would write. So Rusty's age is what we call A plus 4. Okay? Now, does that make sense? Actually, there's no equal sign, so no, it doesn't. Now it makes sense. Okay? Rusty is A plus 4, and A being Spike's age. So all you'd need to know how old Rusty is you just put Spike's age in. Let's say Spike was 12. Okay? If we changed A here with 12, all we would have to do on the right side is change A with 12. And 12 plus 4 would give you 16. So you can figure that out using the equation. Everything I have up here that's digital, not all my drawings, you can include as the answer. And if you want to just put the table in along with these two pieces, all you have to do here then is write A plus 4. So copy down your notes before moving on. All right, here's another one that if we were looking at different ages. Let's say we're looking at Ty's age and Rich's age. And we're given Ty's age as 1. That would make Rich 7. Ty is 2. Rich would be 14. When Ty's 3, Rich is 21. So someone's aging a lot faster than the other. And we can tell that every single time it looks like to get to the next one, we have to see what we're looking at. So to get from 1 to 7, you could either say you're adding 6, but it has to be the same thing every single time. So if we looked at 2 plus 6, does that give you 14? Nope. So we're not adding. So the next operation we'll see here is, let's try multiplying. 1 times 7 gives you 7. 2 times 7 gives you 14. Okay, now here we see a pattern. That's good. So if we did 3 times 7, it should give you 21, which is correct. So really what we have to do to figure out Rich's age is it's always going to be A for Ty, and you multiply it by 7. So 7A, or 7 times A, is always going to give you Rich's age. So at any time we can place a number in for this variable A, and we can find out how old Rich is. Now, anyone know what animal ages 7 human years, or in 1 human year ages 7 years? If you know, come tell me. So I can see that you know your stuff. So the answer here, when Ty's age is A, Rich is A times 7, or 7A. Your choice if you want to write this down or not. Okay, now let's take a look at word problems, because you're going to see tables like this, and you're going to have to try to figure out what the expression is. Okay, so I kind of started showing you this in the last problem. So when you have a situation like this where it gives us a position and it gives us a value, we have to be able to solve for n, figure out whatever it is with n, our variable. We need a variable and a constant to be able to solve the value. So for this one, you really want to look for some relationship between the position, that's the top row, and the values on the bottom row, and of the terms and sequence. So what we want to do is just do a little guess and check. Okay, so our first guess, and I always do this first, and the reason I do this first is because it's the quickest way to get from one to the next. I always try to multiply. So my first guess is this is 7 times n, which means every value here is going to be times 7. So 1 times 7 is going to give you 7, and I think that happens probably every time. Let's see, 2 times 7, oh, that gives us 10. 3 times 7, oh, that doesn't work. So it can't be 7 times n. Okay, we can't just do 7 times 2 because that's not going to give us 10, so that doesn't work. So now what we're going to do is we're going to just try to play around a little bit. Let's try to do a different way to get to 7. Well, we could add by 7, or 1 plus 6 would get us 7. 2 plus 6, that doesn't work. That gets us 8. So let's see if we can look at the 2 and 10 and see a relationship. We know that times 2 won't work. We know times 7 won't work. So let's try something up from times 2. What if we did 2 times 3? That gets us 6, right? And to get to 10, we only need 4 more. Well, that gets us 10. Let's try the same thing here with this one. 1 times 3 plus 4. Well, that gets us 7. Okay, let's try with the 3 here. 3 times 3 plus 4. 3 times 3 is 9, plus 4 is 13. We have found a pattern. We have found a pattern. So whenever we want to find n, all we have to do here is do 3n and then add 4 more to get your answer. So our expression for the sequence is 3 times n plus 4. You kind of just fish around until you find something that works. You find a pattern. So if I said at any time, I'll extend this chart out. If we said, what is, if position is 17, what is the value? Well, to solve this, all we have to do is put 17 in for n. So 3 times 17 plus 4. 7 times 3 is 21. 3 times 1 is 3, plus 2 is 51, plus 4, which is 55. That is how you solve it. Okay? And check your work. So what I want you to write down for the notes here today on this page is the table and the steps here of how I did it. Okay? A lot of notes, but I want you to make sure you have some good notes down. You can paraphrase any way you feel most comfortable with, and then you can move on once you have it. Not needing to write this one down, but you can see a scenario where if we were trying to figure out the area of a triangle any time over and over and over, this is how you can figure out the formula. So if your base was 6 every single time, and your height was 1, 2, 4, and then we're just going to say h, any number after that, you can figure out what the area of it is by trying to figure out what the pattern here is. So after working through it, you can see that you're going to have to multiply the base, which is 6, times the height every time, and then divide by 2. So 6 times 1 is 6, divided by 2 is 3. 6 times 2 is 12, divided by 2 is 6, and so on. So you would find out that if your base was 6 and your height was h, all you would have to do is 6h divided by 2, or what's half of 6? That's 3. You know that you could just do 3 times the height. Or, yeah, 3 times the height. And that could give you any number. So you can use the same thing with formulas that you already kind of know. You don't have to write this down. But if you do want to try it, challenge you to use either this or this, and let's change h to 10 and see what answer you get. I'll be looking for that one when you bring me your quiz at the end of the lesson. Good luck on that one. All right, it's time for the box of thought. You have 2 thoughts I want you to think through and put full sentence answers together. The first one, I want you to describe to me how to write an expression for a sequence given in a table. So tell me what you learned from the tables that we practiced. You can even write an algorithm for this, a step-by-step procedure you're going to use every time. If you want extra help, I would look at resource video example 2 where Professor Berger goes through it. He does a good job. And number 2, explain why it is important to check your expression for all the data in the table. Why is it important to make sure everything lines up perfectly? Should be pretty easy to answer. Make sure you're separating these 2. Like in your box of thought, you're going to put 1 and give your answer. Skip a line and then go to 2 and give your answer. And then box it off. Okay, table it, box of thought. That's how it should be looking in your notes. When you're done with that, it's time for the quiz. All right, your quiz is 3 questions. Figure out what the expression is that goes here for Ray's age. Figure out an expression here for this position and these terms. And then figure out what the area is For L, make that a little clearer. For L, you need to find the length. If your width is 7 every time, what would it be if your length was just L? What's the expression there? Once you got all 3 answers, show them to me at the table, and you are good to go. See you next time.